All right.
So,
My least favorite subject.
yeah. Didn't you count? I didn't
I'm going to call you because the audio is already terrible.
Yeah.
There.
All right.
Oh, yeah. All right, so what do we got with vectors?
So for the first few problems, it says to let a equal -1, 2.
Now, do they mean that like that?
Parentheses.
Not parentheses, but arrows. That's what vector means. Is that what they're talking about?
I think a is just supposed to be a point.
Ah, okay. I kind of got ahead of myself. Okay.
And then b equals 3, 4. C equals -2, 5. And D equals 2, -8.
What's the question?
So the first one is write each of the following in the form z equals x, y. And the first one is vector AB.
All right. First of all, let me go ahead and draw these points. Approximately. It'll be A -1, 2. B will be 3, 4. C will be -2, 5. And D will be 2 -8. Now, what's important to understand about vectors is that if the magnitude and the direction are the same, they are equal vectors. What I mean by that is if I have a vector like this and a vector like this, exactly the same length and exactly the same angle, they are equal vectors. There's only two things that matter about vectors: magnitude and the direction. Doesn't matter where they're located in the XY plane. Okay. So when they want vector AB, they're talking about that vector, which would be the same as that vector. Now, how do I turn this vector into the vector that starts at the origin? Just subtract the x components, subtract the y components. What do you have for this vector?
Do you subtract?
3 minus a -1, which is 4.
Okay.
And 4 minus 2, which is 2.
Right.
So the vector that goes from the origin to this point, 4, 2, is identical to vector AB, which goes from point A to point B. So I'm I'm not sure, but I'm guessing this is what your answer is going to look like. Should be this. And what that means is I'm starting from the origin. I'm going to go 4 to the right on the x-axis, and I'm going to go up 2 on the y-axis. And that's going to give me this vector AB with only one set of coordinates. I don't need 2. The other one is presumed to be at 0, 0.
Okay.
And that's kind of vectors in a nutshell, is that you try to define the vector as succinctly as possible. And if I define A, B as the difference between points A and B, that's a lot of work. But if I define it as strictly the difference in the x coordinates and the difference in the y coordinates, then it's only 2 numbers. And I can assume that the origin was the starting point.
Okay.
Okay, what's the next question they want?
Find vector CD.
All right, let's erase AB. CD. Hold on a second. Let me erase some of this other stuff. So CD is that vector. Now, the starting point matters. But notice that this vector can be defined as also starting at the origin.
Right.
So if I'm going to start it at the origin, what is CD? In other words, if I want to define it as 2 numbers only with arrows like that, what is CD?
4, negative 13.
Yeah, I got to go 4 to the right, and I got to go down 13, starting from either C or the origin. Either one is the same vector. And for that matter, I could start the vector anywhere. As long as it has the same magnitude and the same angle, it's the same vector. That's what matters with vectors. Magnitude and the angle. All right, what else?
All right. So the next one is 3AB.
This completely different? Oh no, 3 times
No,
AB.
same,
Okay.
Yeah, same points though.
Okay. Well, that means 3 times, what was the AB vector expressed? It was 4, 2, correct?
Yeah.
Okay. Well, when you multiply a vector by a number, you just multiply both parts. In other words, that goes to 12, 6. Now, it's worth knowing something about vectors. It's worth knowing. Vectors are not like length or temperature. Length is a scalar quantity. It has only one measurement. Could be in inches, could be in meters, could be in feet, but it's only got one number associated with it. Same with temperature. It could be in degrees, it could be in Celsius, but it's only got one number. Those are both scalar things. Vectors have both magnitude and direction. What are examples of vectors? Force. You can apply a force of a certain magnitude in whatever direction you want. I can push up on something, I can push down on it, I can push to the right, I can push to the left, I can push at whatever angle. And I can push at varying degrees of force. So that's a vector. Another vector is velocity. If you're traveling somewhere, your velocity is the magnitude of the vector, and the direction is whatever direction you're heading. If I'm going to go to Colorado Springs, then I'm going to be headed mainly in a southerly direction. If I go at 60 miles an hour, then I've got a vector. The vector magnitude is 60 miles an hour. The direction is due south.
Right.
All right. What else you got?
The next one is 2AB minus BA.
All right. So we got 2AB minus BA. All right. Well, 2AB is 8 comma 4, right? That was AB. Minus BA. Well, if that's AB, then BA means going from B to A. What do you have to do to get from B to A? You got to go minus 4, and you got to go minus 2.
Minus 2.
So BA is minus 4 comma minus 2. Now, you just distribute these just like XY points. In other words, the resultant vector is plus 12, which is 8 minus a minus 4, and 4 minus a minus 2 is 6. So I wouldn't stake my life on it, but I think that's the answer. Do you have answers on these, William?
I don't know.
Okay. Too bad. It's nice to have answers on material that's a little unfamiliar. When I say unfamiliar, I get vectors every year, but I get it for like a week. And not everybody gets into it. Some people do. So I don't really get enough refreshing on vectors that I would say I'm an expert. That's why when you said tonight's subject is vectors, I said, whatever, oh crap. I do not like vectors. I understand them to a point, but vectors are one of those things that has a 10-point degree of difficulty. Right now we're at 0.2 out of 10. That's the stuff we're doing right now. It's 2 on a 10-point scale, and vectors can go up to like a 9. So I'm fine so far.
Okay.
What else you got?
Find AB plus CD.
All right.
That's pretty easy. You got both of them already.
Yeah, I think once you get the hang of these, the direction matters, as we saw. If you go the opposite direction, the numbers are opposite. All right, AB is 4 comma 2 plus, what was CD? I got to go 4 to the right to get from C to D. So that's got to be 4. And then I got to go 13 down. That's minus 13. Now if I add those two vectors, what do I get?
8 comma
Minus 11.
Right.
2 minus 13, or 2 plus a minus 13.
Right.
So adding vectors, subtracting vectors, pretty straightforward. Multiplying vectors by a scalar quantity, very straightforward. We have not hit the hard part of vectors yet.
Fantastic.
What
Okay.
else? Maybe we won't. Who knows? What else
So
you got?
these next ones have a different values for A, B, C, D.
Different problem? Okay, let me blank the page. What do you got?
A equals -1, 2. That's funny, that's the same as the last one. Oh, dude, it's all the same points. My goodness.
Well, it's all the same points. Let me back up and use this chart. Okay, what do they want to know?
It says compute the following, and it says the absolute value of AB. So that means find the magnitude, right?
Yeah, that doesn't really mean absolute value. It's another case in math where symbols can have duplicate meanings. Normally this means absolute value, but when you're talking about vectors, it means magnitude or modulus. You might hear either of those terms. And what it means,
Okay.
the way you get it, much like the Pythagorean theorem, that's how you get it. It's the square root. It's the square root of the x squared plus the y squared. So in this case, the modulus, I don't know, are you familiar with either of those terms, modulus or magnitude?
I haven't heard modulus before, but that's fine.
Yeah, modulus is kind of more of an unusual one. Magnitude is probably the most common verbal meaning of that. That's the magnitude of vector AB. And that magnitude is 2 root 5.
Okay.
Okay. What else?
The next one is find the magnitude of 2AB.
Well, if we figure out what 2AB is, first of all, what's 2AB?
8, 4.
Now, what's the magnitude of that going to be?
8 squared plus 4 squared. So it ends up being the square root of 80, which is 4 root 5.
There you go.
Not bad.
What else?
Find the magnitude of AB plus BA.
AB plus BA. Well, right off the get-go, we know those are going to look opposite, right?
Right.
In other words, AB was 4, 2. BA was minus 4, minus 2. So when I add those two together, I get 0, 0. Magnitude of that is going to be 0.
Right.
And if you think about it, if I go up and look at my picture, AB is this way, BA is that way. When I add AB to BA, it better be 0.
Right.
That's kind of the essence of vectors. And if you take the magnitude of a 0 vector, you're going to get 0.
So would it be appropriate to say in that sense that there's such thing as negative magnitude?
No, never.
No.
The reason being is that you take the x and square it. That's always a positive number, even if you're talking about a negative number here.
Right.
That's
Okay.
always a positive number, even if it's a negative y. So you're always taking the square root of two positive numbers being added together. You're always going to get a positive magnitude, which is proper because magnitude is like a dimension. I won't say that it's the same as a measurement of, one side of a rectangle, but it is in the sense that it can't be negative. You don't have negative magnitudes. What you have is negative directions. Okay, if I want to go that way, well, I could say that's a negative direction. It's to the left and it's down. So if I'm going that way at 50 miles per hour, my magnitude is 50, and my direction is whatever that angle is. And I can always figure out that angle if I break up. Here's the thing about vectors. You may not have gotten to this yet, but you can take a vector and break it up into its x and y coordinate. By that, let me just say this, because maybe if you haven't gotten to it, it's probably helpful. In other words, if I'm going 50 miles an hour in that direction, that almost certainly is the same as going 30 miles per hour to the west and 40 miles per hour south.
Right.
If I had an airplane going 30 miles an hour west, and I had a wind of 40 miles an hour in a southerly direction, my airplane would end up going 50 miles an hour in that direction.
Okay, right, yeah.
Maybe. All of a sudden that bothers me a little bit. I don't know how we pick up speed.
No, that makes sense, because...
Well, it kind of does.
The forces are additive.
Yes. The ultimate thing with vectors is, let me explain this, because this much I know. Let's say you have a soccer ball in the middle of a field, and you got three people tugging on that ball. One person's tugging with 100 pounds of force in that direction. The other person is a little smaller. He's only tugging with 80 pounds of force in this direction. And then you have somebody tugging in that direction with 120 pounds of force. Now, there's only one scenario where the soccer ball doesn't move. And that's if the x components of all three vectors add to 0 and the y component of all three vectors adds to 0. Then the ball doesn't move because there's no net force being applied.
Right.
If all of a sudden I make that 220 pounds, well then that ball's going to move. This guy is stronger than the other two guys and the ball's going to move in that direction. But I guess what I'm trying to say is that the secret to all vector problems are to take that vector, and as long as I know the angle that that vector is at, then I can figure out its vertical component and its horizontal component. One is the vector times the cosine of theta, the other is the vector times the sine of theta.
Okay.
Let's say it was 50 there. And this angle is 57 degrees, which I think is the necessary angle. Well, that is the equivalent of 30 pounds of force in a due east direction combined with 40 pounds of force in a due north direction.
Okay.
The fact that he is tugging with 50 pounds of force at a 57-degree angle means that we're looking at a 3, 4, 5 right triangle. And if we want to break that 50 pounds up into its horizontal component and its vertical component, we can do it. And in fact, we can do it with all three of the vectors. And the beauty of that is that if we are told that the ball is stationary, nobody's pulling on it, then we know that the x components of all three vectors have to add to 0. And the y component of all three vectors have to add to 0. Otherwise, the ball would be moving.
Right.
So this question can be asked in any number of ways, but one way they might ask it is to tell you the angle of the first two vectors. Let's say that 50 pounds of force is at a 57-degree angle, and tell you the angle of this 100-pound vector, and let's say that reference angle is 30 degrees. And then they would say, what angle must that vector be at for the ball to stay still? And the answer is going to be whatever gives an x coordinate that completely cancels out the combined x coordinate of the other two vectors, or whatever gives a y coordinate that completely cancels out the sum of the two y coordinates of the other two vectors. So this is where vectors become very useful, is when you're dealing with multiple forces or multiple velocities, like you're flying an airplane and you're into a headwind. Your airplane may go 500 miles an hour in still air, but if you're flying into a 50-mile-an-hour wind, it's only going to go 450 miles per hour. And if you have a 50-mile-an-hour tailwind, it's going to go 550 miles per hour. So when you start dealing with things like that, then the only way to really look at them is with vectors. And the one thing that I really have figured, the most important thing about vectors, is taking a vector and breaking it up into its x and y component. And that requires trig.
Right.
Let's just take one example. Let's say I'm taking a 100-pound force that's at a 35-degree angle from the x-axis. Well, that means that the cosine of 35 degrees is going to be equal to my x component over the hypotenuse. So the x component is 100 times the cosine of 30 degrees.
Okay.
And my y component, by the same logic, is going to be 100 times the sine of 35 degrees. So since cosine of that angle and sine of that angle are just numbers, I can certainly figure out what the x component of this 100-pound vector at a 35-degree angle is. And then if I have other forces operating on whatever's at the origin, then I can combine those with the x and y components of this force to come up with a resultant force. Okay. William, I'm sorry, I do have an 8 o'clock that I got to go to tonight.
Yeah, not a problem. Thank you very much, Mr. Count.
Hopefully that's been helpful.
Yeah, very much so.
Vectors can get tough, trust me.
Yeah, it's complicated stuff. That's cool.
Yeah. Talk to you next time.
Yeah, thank you.